In this video, we're going to be simplifying radicals. But before we can simplify them, we need to ask ourselves, how do we know that a radical is in simplest form? And the answer is that you can't break it down anymore. For example, think of the square root of 8. If we were to break it down using a factor tree, we could say that it is multiples of 4 and 2. And 2 is a prime number, so that's as low as it goes. And we can break apart our 4 into 2 and 2. So now that we have all prime numbers, they don't break down anymore. And since we're doing a square root of 8, we need groups of 2. So here's a pair of 2 2's. So that 2 will come out, but that remaining 2 will stay inside. And now we know that we can't break any of those down anymore, and so this will be our solution. So now that we've got that, let's go through and let's simplify some examples. So our first example is a cubed root of 24. So because our n is 3, because we're looking for a cubed root, we'll be looking for groups of 3. So 24 can be broken down lots of different ways. I'm going to do 2 and 12. So 2 is a prime number, so I'll circle that. I'll break down my 12. I'm going to go with 4 and 3. And 3 is a prime number. And 4 can be broken down with 2 and 2. And those are prime numbers. And I'm going to look and see if I can find 3 of a kind, which I can. Here's 1, 2, 3 2's. So I will write 1 2 outside to represent my one group of 3 2's. And then look for any remaining numbers. And the remaining number that couldn't be broken down anymore that was left was 3. And so that 3 will go inside. And that will be our final solution there. So let's look at the fourth root of 48. So because we have a 4 here, we're going to be looking for 4 of a kind. So we'll start off by breaking that down. And this time I'm going to use 24 and 2. And I know 2 is a prime number. Then I'll break down 24. And I'm going to go ahead and use 3 and 8. And 3 is a prime number. And you could have used 12 and 2 again, and that would have been fine, and you would get the same answer. I just thought I would use 3 and 8 this time. So for 8, I'm going to use 2 and 4. And then I'll break down 4 again with my 2 and 2. And now remember that we're looking for groups of 4. So I see that I have a 4 of a kind of 2's. So 1, 2, 3, 4. So I will write down 1, 2 to represent the one group of 4 2's that I found, and look for any remaining numbers. And so that'll be the fourth root with my 3 left over. And so that's important. That got missed last time. If you look at the last problem we did, we left off that 4, or the 3 rather, and that changes your answer completely. So you have to make sure that you write that number so that you can make sure that you're giving the complete answer. So for B, we have 2, the fourth root of 3. 2 times the fourth root of 3 is our simplified solution. So let's do problem C. So problem C is a square root, but we also have an exponent, like a variable there. So what we're going to do is break apart our 75. We'll do our numbers first, so 25 and 3. And then I'll break apart my 25 with a 5 and 5. And those are also prime. And then, so now that I have those all broken down, now I'm going to break down my variable. So here I have x to the third, so I'm going to write down 1, 2, 3 x's. And you'll notice that I've broken them all apart. So they're each their own piece now. So now, because I'm doing square roots, I am looking for groups of 2. So I'll start with my numbers, and I see that I have 2 5's, a pair of 5's. So I can write down a 5, so one group of 5's. But I also see that I have 2 x's. So I can write down an x as well to represent my one group of 2 x's. And that's going to leave me with the square root of my leftover pieces, which are 3 and x. And nothing else can be broken down, and nothing else has been forgotten. And so this is our simplified solution. Why don't you try D and E on your own? And then when you think that you're all finished, go ahead and push play on the video and let's see if you've got it right. So for D, I got 2a times the cubed root of 3a. So I broke down my 24 and I found that I had 3 2's. So I brought out one group of 2's. And I found that I also had 3 a's. So I was able to bring out one group of a's. But I was left with a 3 left over and an a left over. And so those had to go inside of the cubed root sign. Now, number 4 could have been really tricky and probably pretty confusing sometimes. But one of the properties of radicals says that when our numbers, our index, our root, and our 4 are the same, we need to ask ourselves, is this number even or odd? Here it's even, which means that our answer is going to be the absolute value of whatever is inside. So the absolute value of 5x. Well, we can split that apart even farther. Here, let me kind of show you. So we have the absolute value of 5 times the absolute value of x. Well, we know what the absolute value of 5 is. It's 5. So because we don't know what x is, we have to leave the absolute value symbols, giving us 5 times the absolute value of x as our simplified solution. And that's how you can simplify radicals and know if you've simplified your radical all the way.